is a solution to question number 4 on problem solving number 3. And we're asked to solve this particular equation, which doesn't fall into an obvious category. But if we look at this, we can see that we have some quantity that's squared and then that same quantity. So it appears that this is a solution of quadratic type and we can use u-substitution. So I'm going to let u equal this expression x squared minus 12 over x squared. And if I do that, then we can rewrite this equation as u squared minus 10u, and I'm going to bring this 11 to the other side. Minus 11 equals 0. And that looks much more familiar. That's a quadratic equation, and we know how to solve those. This one we can actually solve by factoring, so I'm going to factor this as u minus 11 times u plus 1 equals 0. I need two numbers that multiply to negative 11 and add to negative 10, and that gives us that u equals 11 or u equals negative 1 by the zero product property. But we're really not trying to solve for u, we're trying to solve for x. So now we have to go back and substitute in that original expression. So we have x squared minus 12 over x squared equals 11, or we have x squared minus 12 over x squared is equal to negative 1. So we'll need to solve both of these. So the left, let's work on the left one first. Multiply everything by x squared. So we'll get x to the fourth minus 12 equals 11x squared. Bringing everything to one side and setting the other side equal to 0, we'll have x to the fourth minus 11x squared minus 12 equals to 0. This is also another quadratic type. In this case, we could think of u being x squared. I'm not going to do the u substitution. I'm just going to factor this as x squared minus 12 times x squared plus 1. If you want, you could do another u substitution. I'll write down what you can do. If you want, you could solve this by letting another u, so let's let a be x squared, and then a squared would be x to the fourth. And then you would be able to solve that if you want. So let's continue on solving this. So we have x squared minus 12 times x squared plus 1 equals 0. We're only asked to find real solutions. So x squared plus 1, this particular product, this has no real solution, so we don't need to solve it. We could. The solutions to this are going to be x equals plus or minus I, if you want to solve that. But let's focus on the x squared minus 12. So we're going to have that x squared minus 12 equals 0. Bringing the 12 to the other side, I have x squared equals 12. I'll take the square root of both sides. So x equals plus or minus rad 12. And simplifying that radical, we get x equals plus or minus 2 rad 3. Now let's go over and look at our second equation. We'll do a similar approach here. So we've got x squared minus 12 over x squared equals negative 1. Let's multiply everything by x squared. So we're going to have x to the fourth minus 12 equals negative x squared. Bring that negative x squared to the other side. We'll have x to the fourth plus x squared minus 12 equals 0. If you want, you can do a u substitution. You can let u be x squared, and then you'd have u squared plus u minus 12 equals 0 if you want. I'm going to factor this directly. This factors as x squared plus 4 times x squared minus 3 equals 0. Once again, we're looking at the first expression here. This also has no real solutions. If you want to solve this, you'll get x equals plus or minus 2i. Let's focus on the one that has real solutions. So we have x squared minus 3 equals 0, so that means x squared equals 3. We'll solve square root both sides, so we get x equals plus or minus rad 3. And this asks us to find the largest. So the largest real number between plus or minus 2 rad 3 and plus or minus rad 3 is 2 rad 3.